Lincoln, one of the big questions that we get is about how the aluminum posts are manufactured, and they've heard a lot about automation happening. And I was hoping that you could walk us through the process of how you go from this raw material that comes in all the way through a post being made.
So the raw extrusion comes in from our vendors. We'll store it up on the rack. This is kind of where it comes and where inventory starts.
I understand that this aluminum extrusion, it's pretty local. It's coming from just a few miles up the road, is that correct?
That is correct. As the material comes off the shelf, we actually have a separate staging area behind the razor gauge system, which is where we automate and cut our product, basically. Viewrail here will actually go through and actually cut one of the posts. So we'll actually load up a cut list per size. It'll actually automatically push and razor gauge down and make a cut after cut, which is really nice on actually not having to measure things out.
Man, that saw is going through that thing like butter.
Oh, every time.
Oh, it pushes it all the way up there in place. I can see how this automation really is changing your game.
Once the post is ready for production now we will pre-stage, and by cut length, we'll bring it over to our automated welding, machining, pressing top cell. There's a lot that goes on over here.
Okay.
Next step is going to come over to the press-in top machine. So basically, the raw tube that we had coming off the saw will be grabbed by the operator, and we use a press-in top that comes out of our lathe department. So our lathe department will machine this press-in top. That will recess in and set down into the top of the post.
I see.
We'll actually load it into the jig fixture, which is fully automated, and now we're ready to actually press the top into the post.
So this ram is just going to shove that thing all the way down in there?
It'll actually fault out, give us a green score, which is good. This post is good for manufacturing. Basically, if we get a red light, that means there was maybe a malfunction inside the extrusion wall that we actually have on the tube, or the machine top will be bad. Basically, anything that's bad is under a 1,200-pound pull-out strength.
Bad is 1,200 pounds?
It's 1,200 pounds.
So what's good?
Good's anything greater than 1,200. We are 99.99% green light. That means we have a pull-out strength greater than 1,200 pounds.
Pretty neat. I'm loving it.
This here is our aluminum robot welder. So this is an OTC die hand, and this is actually where we'll automate and actually weld the foot onto the post. The foot is what you mount the surface to with a robot.
Okay. Well, hey, Tim, how you doing today?
Pretty good. How you doing?
So, Tim, you've got this big robot here and this positioner. Now, I know you're a pretty accomplished fabricator and welder yourself. How do you feel about this robot and the work it is doing?
Well, the robot, every weld's going to be consistent, and since it's automated, it frees me up to do other things in the shop.
So some of the company values are really coming to life right here of you being able to unleash your imagination while the robot's doing the work.
Correct.
That's really neat. Winding back, when you first came, how many posts were going through the cell in a day?
We were averaging anywhere between 25 to 40, somewhere in there. Right now, each day we're right around 300 to 450 a day.
450? Did I hear that number?
And it's going up. What you see behind you, this cell, and along with other cells that we develop, automation has taken basically what we could do and has increased capacity by tenfold. Not only capacity, but holding consistency every day.